Relations, functions, and function notation. A relation is when you take input values and you match them to output values. You've done this before when you make an equation like y equals 3x plus 5. You take values you put in and you get values out. That's a relation. The values you put into the equation are called the domain, all the values you put in, and the values you get out are called the range. So the domain refers to the values that are input into the equation. Range refers to the values that are output of the equation. If a relation meets certain conditions, it's called a function. And a function is what we work with most of the time in mathematics. And the rule is there's only one output for each input. Now that's kind of confusing, so we're going to use some function diagrams to think about this. So let's start with the bottom left one. Notice how even though 1 and negative 1 go to the same value 1, each input has a single output. So that is a function. It meets all the conditions for a function. Every value I put in goes to one value when I get out my output. Look at the bottom right one. It is a function because every value, like 3, goes to a single value like 7. In all cases, every domain, every element, goes to a single value in the range. However, if you look at the top right one, you'll notice that negative 1 goes to two different values. It goes to 1 and negative 1. This violates the rules. It is a relation, but it violates the rules that make a function. This is not a function. The bottom two are. Let's look at some more examples. Take a look at the graph. Every value in the domain, these are the x's, must have a single value in the range. These are the y's. Notice how 3 gets assigned to two different values. This violates the rules of a function because I have an element in the domain that has more than one element, that is assigned to more than one element in the range. And would this make sense if this was a real life scenario? If I was graphing time versus savings, after 3 years, would I have two different savings amounts? If I'm tracking my savings, there should be a single amount that describes what I have saved. It doesn't make sense in the real world. Or if I was graphing time versus population and population was on the y-axis, would it make sense after 3 years to have two different populations if I was tracking the same animal or whatever it was? Every value in the domain must have a single value in the range. So we can look at a graph and tell if they're right on top of each other, if there's any points that are, it's not a function. And this brings up the vertical line test. If you can draw a vertical line and hit 2 points, that means that there's a value in the domain that has more than one value in the range assigned to it. So the vertical line test, a very easy way to tell if a relation is a function. Let's look at these other mapping diagrams. Notice how, let's start right here. Every value in the domain has a single value in the range. This is a yes. Bottom right. Do you see how 6 gets assigned to two different values in the range, 3 and 5? This is not a function. This is no. In the top right, every single value goes to a single value. So this is a function. This is a yes. Let's practice the vertical line test. Watch how quick this goes. If I can draw a vertical line, then there's an X, that has more than one y assigned to it. So do you see the vertical line? This is a no. This is not a function. Next one, this is called an ellipse, the oval. If I can draw a vertical line and hit 2 points, then it is not a function. This also is a no. In the bottom one here, every vertical line only hits 1 point. So every value in the domain, every x, gets assigned to a single value in the range. So this one is a yes. Top right. If I draw a vertical line, I'm only going to hit 1 point. This one is a yes. This is a sideways parabola. I can draw a vertical line. There's one that exists that hits 2 points. So there's an x that has more than one y. This is a no. And the last one in the bottom right, is there an x that has more than one y? Well, not here, not here. Uh-oh, right there. I can draw a vertical line and hit 2 points. This one is a no. Here's some mapping diagrams, ordered pairs, and tables. Let's see if these are functions. In this first one, 3 gets assigned to more than one value. So this one is a no. In the second mapping diagram, this is a function because every value in the domain, these are the x's at the top, and these are the y's. Every value in the domain has a single value in the range. So this one is a function. Look at the two sets of ordered pairs. Every x has a single y. So this one is a function. In the bottom one, the clue is that you see how we have an x, -2, that occurs twice? -2 goes to two different locations. It's exactly this situation right here. -2 goes to 4, -2 goes to 3. We have an element in the domain that goes to two different values in the range. This one is not a function. The trick I just showed you works in the table. You see how 2 occurs twice? 2 goes to 8 and 2 goes to 12. This one is a no. In the second table, every x has a single y value. So this one is a yes. And again, the last table, you have 0 occurring twice. 0 goes to -3, 0 goes to -1. This one is not a function. Function notation has a bunch of uses, but for us, it's a way to show the input and the output in the same equation. Remember when we take equations like y equals 3x plus 5, and we'd make tables, and we put in values. 3 times 1 plus 5, that's 8. 3 times 2 plus 5, that's 11. 3 times 3 plus 5, that's 14. And if I put in 4, I'd get out 17. Well, we can do this type of equation, y equals 3x plus 5, in function notation. And we write it as f of x equals 3x plus 5. And if I ask you to plug in, say, 0, what's f of 0? All that means this is the x that we put in 0. 3 times 0 plus 5. And that gives me 5. And if I ask you what f of 1 is, again, the 1 is your x. The 1 is what you're plugging in. 3 times 1 plus 5. Well, look at the table. That was 8. And if I ask you what f of 2 is, that means you're going to plug in 2 for x. That's your x. 3 times 2 plus 5, and that was 11. And what would f of 3 be without any work? 14. And f of 4 would have been 17. So I can see the x and the y in the same equation. In each case here, this is the x, this is the y. This is the x, this is the y. X and then y. So with function notation, we can see the x we plug in as well as the y we get out of an equation all in one expression. We've already talked about how the input values are the domain, the output values are the range. We also name the variables. If I take that equation we just used, y equals 3x plus 5, the values I put in are the domain, but the variable itself, the x, since I can put anything in for x, it's independent. But y will depend on what I put in for x. Y depends on x. So y is called the dependent variable. So the values we put in are the domain for x and the range for y. The variables themselves are independent or dependent. And if it's independent, that means I can put anything in I want. But what I get out depends on what I put in, so that's why y is dependent. And writing y equals 3x plus 5 as f of x equals 3x plus 5 is exactly the same thing. I can always interchange y and f of x whenever I feel like it. They are the same thing. F of x just means I can show the x I plug in. So remember that y is the same thing as f of x, and I can always replace f of x with y, and this is the dependent, because y depends on what I put in for x. We hit a lot of topics here. We don't talk about relations very much because we generally work with functions. Not always, but most of the time. A function is a relation. It's just a relation with special conditions. Every input must have a single output. And function notation, just the idea that I can replace y with f of x and show what I put in for x as well as what I get out for y.